there's something I want to mention and talk about, and I will repeat it in class anyway on Friday. So let's do these first because these are the easy ones. 2 factorials, 2 times 1, 3 factorials, 3 times 2 times 1, 4 factorials, 4 times 3 times 2 times 1. Let's see, that's 4 times 3 is 12. 12 times this 12 is 144, times 2 is 288. 4 times 3 and then the factorial, so that's 12 factorial. I'm going to leave it like that. All right, you can I'll find a setting in the calculator where we can just plug that in. 4 times 3 factorial, so please don't multiply the 4 and 3. Order of operations is 4, and then times 3 times 2 times 1, or just 6, right, if you remember. That gives us 24. Letter D, it's 4 factorial minus 3 factorial. Well, we know what 3 factorial is already, right? That's 6. 24 factorial, it's, let me write that, 4 times 3 times 2 times 1, it's 12 times 2, which is 24. If you subtract that, you get 18. The bottom one is 8 factorial over 5 factorial. If you actually expand this, you'll notice that from 5 on, it'll be simplified to 1. Right, so all this goes away. So you're left with 8 times 7 times 6, which is 56 times 6, which is 336. The bottom one is 8 factorial over 0 factorial. We mentioned that 0 factorial was 1, and we'll talk about it in class again on Friday as to how we can sort of guess, maybe look at patterns and see why, where we get that 0 factorial is 1. So that's 1, and this is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which no one wants to do. 6 times 5 times 4 times 3 times 2 times 1, and that gives you 40,300. All right, so this is a good problem. There's 2 ways of doing this, using the fundamental counting principle, which states, right, remember, is the number of events that's happening here, however many choices you have, times the number of events on the second one, right? Number of choices in the first event times the number of choices in the second event, right? So, and then we had, well, we talked about the permutation formula, which is n factorial over n minus r factorial, when to use each one. If repetition is allowed, okay, if repetition is allowed, I want you, repetition is allowed, I'm going to use this one. If there's no repetition, I'm going to use this one. And repetition. Okay. Let's go to, let me give you an example. Let's say we have the word cat. And let's do the one where it's repetition. But let's do the word cat and I have 2 spots. How many arrangements of 2 letters can I make from the word cat with repetition? With repetition, well, now if you think about it, so here I have 3 choices. I can put a C, an A, or a T. On the second spot, I can put a C, an A, or a T because I'm allowed repetition. So that would be 3 times 9, 3 times 3, which is 9. Let's see if we can get that. So it'd be a C and A C and T, and I forgot the C and C. It could be an A and a C, A and a T, and it could be an A and an A. It could be a T and an A, T and a C, and a T and a T. So here are my 9 choices. Now, if you can't have the repetition, and that's, the problem we did in class earlier, the 3 friends, Charlie, Alex, and Tommy, and we want to make pairs. How many different pairs can we make? Well, we can have Charlie and Alex, Charlie and Tommy. We can have, right, standing in the back for the picture, right? They can stand, these 2 can stand next to each other. Then we can have Alex and Charlie, Alex and Tommy, and Tommy and Charlie, Tommy and Alex. Notice that Charlie cannot be in 2 spots at the same time, so repetition is not allowed. So we have 6. Well, we had 3 choices in the first spot and 2 choices for the second spot, which equals 6. Now, using this, right, we had a total of 3 choices taken 2 at a time. So if we use the permutation formula, we had 3 factorial over 3 minus 2 3 factorial is 3 times 2 times 1, and 3 minus 2 is, sorry, parentheses, 3 minus 2 is 1, and 1 factorial is just 1. Simplify, we get 6. Okay. Yeah, so let's go back now to the problem. Okay, so remember, repetition, fundamental counting principle, no repetition, we can use the permutation formula. How many 4-letter code words can be formed using a standard 26-letter alphabet if repetition is allowed? So you're making 4-letter words using the 26th letter of the alphabet, and they're telling you that this is allowed. A. Right? So if repetition is allowed, we're going to just use, well, the number of choices here is 26. Number of choices here is 26. Number of choices here is 26. And the number of choices here is 26. So that gives me 26 to the 4th power. Now, if the what do you call repetition is not allowed, now we can go back to that same problem. We have 26 kids. We're going to put 4 in the back row for the class picture. How many different arrangements of 4 can we do? So that's basically what this is, right? 26 people taking 4 at a time. So we have 26 factorial on the top. The bottom is 26 minus 4, which is 22 factorial. If you expand that out, remember, it's 26 times 25 times 24, so I'll write a few. 25 to 24 times 23 times 22 dot 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 over 22 times 21 times 20 dot dot dot. So notice that everything from 22 down will be simplified. So we're actually left with 26 times 25 times 24 times 23, which here's a shortcut, right? 26 choices, 1 is already there, so the second time around you only have 25 students, 24, 23. So if repetition is not allowed, 26 times 25 times 24 times 23, we get 358800. Okay. The bottom one. So first one says no repetition of letters, which means that digits can be repeated. So it's like a combination of both. So if no repetition, we have a license plate. 1, 2. The first 3 are letters. I think we did this in class, but I just want to go over it. These are digits. The letters you can't repeat. So we're taking 26 letters, right? And there's 26 that taken 3 at a time. So we can do that. Times, well, the digits can be repeated. So this will have 10 choices. I'll have 10 choices here, and I'll have 10 choices here. And that's what I'll do. 26, right, taking 3 at a time is actually, well, if you look at it let me do it the long way. Well, it's going to be 26 factorial over 26 minus 23, which is 23. 26 minus 3, which is 23 factorial, right? So actually, let me write this a little bit lower. 26 factorial over 26 minus 3 is 23 factorial. Now, if you expand it out, notice that 23 factorial is going to simplify with everything from 23 down. So you actually are left with 26 times 25 times 24 times 23. So you're left with 26 times 25 times 24 times 24. That's it. And then I'll put these numbers here. All right, so part of it, right, it's permutation, and the rest is not. So 26 times 25 times 24 times 1,000. Oh, that's a lot of license plates. 156,00123. 15,600,000. Now the second part says neither of them can be repeated. So 1, 2, 3 can't be repeated for the letters, and the digits cannot be repeated. Now the short way of doing this is going to be 26 times 25 times 24, because once you use one letter, you can't use it anymore. Same goes for the digits. Once I use a digit, when I go back to the second spot and I have to select another one, I have one less choice. Now that is the short version of this. Right? Because, and again, 26 factorial over 26 minus 3 factorial times 10 factorial over 10 minus 3 factorial, right? And this is going to become just 23 factorial because you're going to, this, once you subtract 26 minus 3, you're left with 23. So you're actually left with this 26 factorial over 23 factorial times 10 factorial over 7 factorial. Right? And then if you simplify, you actually get these two numbers. Okay? Which you can multiply and find the answer. Combination lock has 40 numbers on it. I don't think you guys have you ever seen a combination lock? Remember, it's something like this, and then you had a little die on the middle, and then all these numbers, and you had to like go right one, and then go two to the left, right? In the old days when you used to have lockers, kids used to use. I used to use that. I don't think. Maybe when you get to high school, you have one with high school with lockers. Okay, so question 1: how many different three-number combinations can be made? But question 2 says how many different combinations are there if the numbers must be all different. So B, because the numbers have to be all, you can't repeat it. That one would be, here's 40 numbers taken 3 at a time, right? And they all have to be different. And then how many different three-number combinations can be made? I don't say so. Because I'm reading B, and B says different combinations, that's a permutation, because if like the first number is 40, the second number can't be 40 again, right? So for that one is a permutation, right? We're taking an arrangement of 3 at a time from the same group. So let's just do that one. 40 factorial, and at the bottom is 40 minus 3, and then take the factorial. So that we're left with 40 factorial over 37 factorial. If you simplify, right, you're going to be left with 40 times 39 times 38. So 40 times 39 times 38, and that gives me 40 times 39 times 38 gives me 59,280. I'm going to hold off on A, because if this is different, the numbers have to all be different. How many different three numbers combination? But this one could be where they can be repeated, so I'm going to say 40 times 40 times 40, or 40 to the third power. Put a question mark there. Okay, you have the digits 1, 3, 5, 7, 9. No repetition. Good. So how many one digits can you make? Wow. Really? Again, I'll do it just because we're doing permutation. So we have 1, 2, 3, 4, 5 numbers taken one at a time. How many different arrangements can I have? Well, it's 5 factorial over 5 minus 1 factorial, right? So 5 factorial is 5 times 4 times 3 times 2 times 1. 4 minus 1 is 4 factorial. So it's 4 times 3 times 2 times 1. Cross, 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 cross. And that was obvious, right? If there's only one digit and you have 5, well, you can have a 1, a 3, a 5, a 7. I said 5 different choices. That was obvious. 2 digits. Okay? So we're taking 5, 2 at a time. So 5 factorial over 5 minus 2. And the factorial, so it would be 5 times 4 times 3 times 2 times 1 over, and 5 minus 2 is 3, so we're going to do 3 times 2 times 1. Simplify, simplify, simplify. We get 20. So we can get 20 different arrangements. Third one, 3 digits. And again, hopefully by now you've sort of seen a shortcut, right? So we get 5 P3. That doesn't look like a P. P3. So it's going to be 5 factorial over 5 minus 3 factorial, which is 2 factorial. So that's 5 times 4 times 3 times 2 times 1 over 2 times 1, which you could have just done 5 times 4 times 3, right? Same thing. And then 4 digits, 1, 2, 3, 4. The quick way, you have 5 choices here. If you take one out, right, you're going to have 4. You take another one out, you're going to have 3. Take another one out, you have 2. Again, I'll just do this. You have 5 choices, right? 5 different choices. And taking 4 at a time would be 5 factorial over 4 factorial. 5 times 1 over 4 times 3 times 2 times 1. Simplify, simplify, simplify. Oops, hang on a second. I did that wrong. I subtracted incorrectly. 5 minus 4 is 1 factorial. Oops. So it's 5 times 4 times 3 times 2 times 1 over 1. That simplifies. 4 and 3 is 12. 5 and 2 is 10. So that gives me 120. Right. All right, moving. 5 members of a math club. How many ways can the positions of office of president, treasurer be chosen? Well, order is important because the first person will be the president, and the second person will be the treasurer. So completely different positions. All right, so that would be 5 people taking 2 at a time. So 5 factorial over 3 factorial, which is 5 times 4 times 3 times 2 times 1 over 3 factorial. Or you could have just done 5 times 4. Same thing, equals 20. Okay. Baseball team has 9 players. Find the number of ways the manager can arrange the batting order. So we have 9 people taking 9 at a time, right? Arranging them at 9 at a time. So this is 9 factorial over 9 minus 9 factorial, which is going to give us 9 factorial over 1 factorial. So this is going to be, and again, if you think about it, the quick way was 9 choices for the first spot, 8 choices for the second spot, 8 choices for the second spot, 7 choices for the third spot, and so on and so on. That's the same thing as 9 factorial. Okay, I'm not going to multiply. 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. I don't know why I did the 1, but I did it. 3, 6, 2, 8, 8, 0. So batting order, we can have 306,880 different lineups for the 9 members, 9 people in the baseball team. Find number of ways of choosing 3 initials from the alphabet if none of the letters can be repeated. So again, from a group of 26, we're taking 3 at a time. So how many different arrangements can we make? So quick way, find 26 times 25 times 24. The long way, 26 factorial over 26 minus 3. Take the factorial, so it's be 26 factorial over 23 factorial, which eventually this becomes that. Okay. All right, just a few more. So A, and I'm quickly going to do that, would be 6 factorial over 3 factorial. If you simplify, it becomes 6 times 5 times 4, so that's A, right? That's 120. B is 10 factorial over 10 minus 2, 8 factorial. If you simplify, you just are left with 10 times 9, which is 90. C is 25 factorial over 25 minus 2, which is 23 factorial. And you're left with 25 times 24, which is 600. D is 4 factorial over 1 factorial, because 4 minus 3 is 1, so it's 4 times 3 times 2 times 1, which is 24. E is 20 factorial over 18 factorial. So that is just 20 times 19, which is 380, I think. Sorry. E, F, wife calling. 1 second. Hello. 몰라. 집에 와 있다. Okay. No, I don't know. Like, okay, all right, so whatever you want. Soft. Okay. Easy. Something easy. Okay. I don't know. You figure it out. 나 텍스트 보내. 나 지금 비디오 만들고 있어. Okay, bye. Sorry. Dinner is always an issue because we never know what to eat. So 11 factorial over 7 factorial is 11 times 10 times 9 times 8. Okay, 11 times 10 times 9 times 8. 7,920. G, right, so it's 22 factorial over this difference between 22 and 3, which is 19 factorial. So after you simplify, you're left with 22 times 21 times 20 times 20, and that's 9,240. H, 10 factorial over 6 factorial. 10 times 9 times 8 times 7. I, and 10 times 8 times 7 times 10 equals, that's 5,040, by the way. I, 7 factorial over 7 minus 6 is 1 factorial, so that's just 7 times 6 times 5 times 4 times 3, oops, times 2. We get 5,040 again. What is that, 9? J, okay, 101 factorial over 101 minus 3 is 98 factorial. So after you simplify, you're left with 101 times 100 times 99. 101 times 100 times 99. Oh, you get 999,900. Then we have K, again, 8 taken 5 at a time, so it's 8 factorial over the difference between these two, which is 3 factorial. And we're going to have 8 times 7 times 6 times 5 times 4, because everything else will simplify out. 7 times 6 times 5 times 4, and that's 6,720. L, 6 items taken 6 at a time will be 6 factorial over 0 factorial. So that's just going to be 6 times 5 times 4 times 3 times 2 times 1. 5 times 4 times 3 times 2 times 1, which is 720. Okay. 2, how many 3-letter words can be formed from the given letters if each letter is only used once in the word? So all these would be permutations, right? So lion has 4 letters. We're going to take 3 at a time. So it's 4 factorial over the difference of 4 minus 3, which is 1 factorial. So that is 4 times 3 times 2 times 1, which is 24. With tiger, there's 5 letters. So 5 letters taken 3 at a time. 5 factorial over 2 factorial. That's going to simplify to 5 times 4 times 3, right? And that's just, what is that? 60. Monkey has 1, 2, 3, 6 letters, so 6 taken 3 at a time. So again, 6 factorial over 6 minus 3 is 3 factorial. That's going to give us 6 times 5 times 4. And that's going to give us 20 times 6, 120. Leopard has 1, 2, 3, 4, 5, 6, 7. 7 taken 3 at a time, 7 factorial over 4 factorial. So that leaves us with 7 times 6 times 5, which is the 30 times 7, 210. And then man. It's going to be 3 factorial over 0 factorial, which is just 6. Okay. 30 students in a class. Each day the teacher calls on different students to write homework problems on the board, with each problem done by only one student. How many ways can a teacher call students to the board if the homework consists of one problem? If there's only one problem and there's 30 students, right, she has 30 choices. Right? So if you think about this, it's going to be 30 factorial over 29 factorial, which is going to be just 30. If there's 2 problems, then she has a choice of 2. 30 students taken 2 at a time. Now, we can just do 30 times 29, but I still want to show you, so you can get used to it. So it's 30 factorial over 28 factorial, and that ends up being that, right? 30 times 29, so there's 870 arrangements that can happen. If there are 3 problems, I have to call 3 people. So 30 students, taking 3 at a time, it's going to be 30 times 29 times 28. That's a shortcut, right? So 30 factorial over 27 factorial. Everything from 27 down gets simplified, leaving you with that. So 30 times 29, 30 times 29 times 28, 243,000, sorry, 24,360. Horses in the race, okay? Again, permutation, because same horse can't come in first, second, and third place at the same time, right? So again, 7 horses, taking 3 at a time, where order does matter, right? So we're going to have 7 factorial over 4 factorial, which is the same thing as 7 times 6 times 5. So 7 times 6 times 5, 210 ways. There's 9 horses, right? So it's going to be 9 factorial over 6 factorial, which is the same thing as 9 times 8 times 7. That's 504 different ways. If it's 11 horses, it'd be 11 factorial over 8 factorial, which is the same thing as 11 times 10 times 9. 11 times 10 times 9 is 990. And for the last problem, NP3, it would be n factorial over n minus 3. Leave it in parentheses, please. That's it, right? I mean, sort of fun.